Welcome, students. In a nutshell, whenever we're talking about the classifications of matter, these are the kinds of questions that we need to be able to answer. So I'll just talk us through the classifications of matter from the AP perspective, making sure to emphasize everything you'll need to address these questions and a little bit more. So let's get started. Matter, anything that has mass and takes up space, can be most simply classified as mixtures or pure substances. What is the difference? Mixtures are two or more samples of matter, elements and elements, element and compound, two or more compounds, elements and mixtures, two or more mixtures that can be physically separated. They can be physically separated from each other. Pure substances cannot be physically separated. There are two kinds of mixtures, homogeneous and heterogeneous. Homogeneous, the prefix homo being describing the same, is the same throughout the composition. Homogeneous mixtures are also known as solutions. Heterogeneous mixtures differ in their composition. For example, a lot of food items, a bowl of Lucky Charms. One spoonful may have 2 Lucky Stars, another may not have any of the marshmallows. It varies in its composition. Remember, samples like milk, even skim milk, are heterogeneous. I know it's not evident to the naked eye. Again, a lot of food products, fresh squeezed orange juice, mixed salad, pepperoni pizza, heterogeneous. Solutions, lemonade, not fresh squeezed. Hydrochloric acid, the air that we're surrounded by, solutions. They all can be physically separated. Well, what are some methods of physical separation in chemistry? Physical separations rely upon physical properties for their separation. For example, by hand. You can separate out the different color M&Ms by hand based upon their color, their physical property. We could separate out anything magnetic from anything that is not magnetic by running a magnet through the mixture using the property of magnetism. You could utilize density to separate sand from water by allowing gravity to enact and pull the sand crystals down. That's also separating based upon size, which would happen with a filter. We could separate a precipitate from a liquid, sand from water with a paper filter. You're separating based upon size. Evaporating. If we have Kool-Aid, we could drive away the water, so we're separating based upon boiling point. A centrifuge utilizes centrifugal force to separate substances based upon their different masses. Chromatography, remember who stole Mr. Mole? That is separating components based upon their different amounts of attraction to the paper or the solvent running through. Distillation. This is often used when you have a sample of 2 or more liquids and you are placing them together and gradually increasing the temperature. You separate them based upon their boiling points. You're monitoring the temperature. When you reach the temperature of the first boiling point, that will vaporize. You then could put it through, and this is a distillation apparatus that would then cool the vapor to then retain that pure liquid. You then would gradually warm to get to the next component's boiling point, collect that, and so on and so on. So these are some common examples. Zumdahl does a beautiful job within your textbook talking further about some of these. But those are the main ways in which we can physically separate the components of a mixture. You cannot use those methods to separate what are pure substances, and those are elements and compounds. Now, What makes an element is it can be neither physically nor chemically separated. A compound cannot be physically separated, but it can be chemically separated, of course giving us the elements that were chemically combined to yield the compound. Examples of elements, periodic table, and we sure are familiar with tons of compounds. Elements could further be divided most simply into metals and nonmetals. Of course, we have that category of metalloids, but most commonly we just say metals and nonmetals as far as reactivity. Compounds, we could break into ionic and covalent. We could get a category of what would be acids, and so on. So that is a reminder of the different classifications of matter. An emphasis this year will be on visualizing, very much on visualizing. So, given different pictures, can we answer, apply this understanding of solids, liquids, and gases, as well as the different classifications of matter, to be able to, say in this instance, say in comparison to each other, what would be solid, liquid, or gas? Hands down, in comparison, solid, liquid, gases. Not much empty space, and we have some order. A little bit more empty space, but not much order. We can see possibly these could exchange places, where these have approximately the amount of separation, at least 10 diameters of separation from one gas particle to another. So we would say in the gaseous state. Now what about which is an example of an element, compound, or mixture? Well, I would venture to say the spheres are probably representing individual elements. Here we have 3 samples, one that's shaded in, one that's larger. So I would say this is a mixture of 3 different elements. And I don't think we can venture just with 3, one of each, to say if it's homogeneous or heterogeneous. This looks like these elements are bound in compound form. So I think this is just a sample of the compound. This, we could go different routes. I would venture to say this is either a homogeneous mixture of 2 different elements, or possibly a single compound if we want to predict that this solid sphere and then this lighter sphere is actually representing a compound. And that definitely looks homogeneous to me, but that would be an example of a compound. So either a homogeneous mixture with 2 elements, very, very consistently repeated in their pattern. These look like individual compounds, and since it's only compound, then not the issue of mixture. So liquid state, compound, gaseous state, compound, element form, but mixture because we have 3 different elements, but we can't predict homogeneous or heterogeneous. This, definitely solid. I'm going to go ahead and say this is probably a homogeneous mixture of 2 different elements. Thank you.